My name is Mr. Corbin. We're going to go over the AMC8 that you guys all just took. I hope that if you took my mock exam or the mock exam that we all made for iLearning, that you felt like this was easier than the mock exam. I tried to make the mock exam a little bit harder, but there are still some problems on this test that are really interesting to me. So, for instance, let's start with problem 1. If we group it like this, we get 0, 3, 6, and 9. That adds up to 18, which is A. Here we have 3 3s, and then around that we have 4 times 3 2s. And then around that we have 4 times 5 1s. And so that is equal to 9 plus 24 plus 20, which is equal to 53. Okay. I'm going to be looking at chat occasionally. If I'm going too fast, let me know. Usually for 90 minutes, I would give everyone a 5-minute break halfway through. However, I'm just going to try to go as fast as I can for this one. Again, if I'm going too fast, let me know. If you have any questions, let me know. It's never too late to go back and explain something. So Haruki has a piece of wire that is 24 centimeters long. He wants to bend it to form each of the following shapes one at a time. A regular hexagon with side length 5 centimeters, a square with area 36 centimeters squared, and a right triangle whose legs are 6 and 8 centimeters long. How many shapes can Haruki make? This one has a perimeter of 30, so this one's impossible to make. This one has a perimeter of 24, so this can be made. And this one has a perimeter of 6 plus 8 plus the square root of 6 squared plus 8 squared, which is equal to 6 plus 8 plus 10 equals 24. So this one can be made. The answer then is D, the square and the triangle only. So Bryn's savings decreased by 20% in July and then increased by 50% in August. Bryn's savings are now what percent of the original amount? So if a decrease by 20% means that Bryn is at 80 out of 100% now. And an increase of 50% means that Bryn is now going to 150%. Pardon me, my tablet appears to be lagging a little bit. Let me try plugging it in. And that's over 100. All right, so before we multiply, I'm going to try to simplify. So we have 8 times 15 over 100, which is the same as 120 over 100. So that's E. Casey went on a road trip that covered 100 miles, stopping only for a lunch break along the way. The trip took 3 hours in total, and her average speed while driving was 40 miles per hour. In minutes, how long was the lunch break? So if she's going 40 miles per hour in 2 hours, she goes 80 miles, and then in another 30 minutes, she'll go 20 miles. So overall, she had 2.5 hours. If it took her 3 total hours, then that is a half an hour break. All right, so Peter lives near a rectangular field that is filled with blackberry bushes. The field is 10 meters long and 8 meters wide, and Peter can reach any blackberries that are within 1 meter of an edge of the field. The portion of the field that he can reach is shaded in the figure below. What fraction of the area of the field can Peter reach? So what we have here is going to be good over total. I'm going to rewrite that, though, as total minus bad over total. So we're going to have 8 times 10 minus, and then this area, this is going to be 6 long, this is going to be 8 long, so that's 6 times 8 over, and then 8 times 10. All of these have 8s, so this is 10 minus 6 over 10, which is the same as 4/10, which is the same as 2/5. So that's E. All right, so then Mika would like to estimate how far she can ride a new model of electric bike on a fully charged battery. She completed 2 trips totaling 80 miles. The first trip used, totaling 40 miles. The first trip used 1/2 of the total battery power, while the second trip used 3/10 of the total battery power. How many miles can this electric bike go on a fully charged battery? So we have 1/2 plus 3/10 times the total amount of a battery. I'm going to call that B is equal to 40. Or 8/10 of B is equal to 40. And so 4/5 of B is equal to 40, or B is equal to 50. So the answer is C. All right, and a poll asked a number of people if they liked solving mathematics problems. Exactly 74% answered yes. What is the fewest possible number of people who could have been asked the question? All right, so the way that we're going to figure out the fewest number of people is we're going to take this percentage, 74%, and we're going to write it in the most reduced way as a fraction. So this is equal to 37 over 50, but we can't simplify that anymore. Since we can't simplify that anymore, then a minimum of 50 people could have been asked the question. All right. I'm going pretty fast right now. I'm doing less than 1 question a minute. So if you have any questions, feel free to ask. The square root of 81 is 9, and the square root of 16 is 4. The square root of 16 times 9 is the square root of 16 times the square root of 9, and similarly the square root of 81 times 4 is the square root of 81 times the square root of 84. So this is 4 times 3 over 9 times 2. This cancels, this cancels, this cancels, this cancels, and we're left with 2/3, which is B. All right, so 5 runners completed the grueling X marathon: Luke, Melina, Nico, Olympia, and Pedro. So Nico finished 11 minutes behind Pedro. Olympia finished 2 minutes ahead of Melina, but 3 minutes behind Pedro. Olympia finished 6 minutes ahead of Luke. So which runner finished 4th? Well, we have Olympia is greater than Melina, but less than Pedro. However, this is a distance of 5 or 7. It doesn't matter because this is a distance of 11. So Nico is 4th, so that's C. Oh, did I make a mistake? I made a mistake.
Isn't it Luke?
It is Luke. I haven't even written Luke down. Olympia finished 6 minutes ahead of Luke. I haven't even written Luke down. Okay. We need to know who is last out of these 5. So we have Pedro, Olympia, Melina, and then we have Nico and Luke. Yeah, Luke is between Nico and Melina because Nico's still in last. So then the 4th person here would be Luke. Cool. All right, so squares of side length 1, 1, 2, 3, and 5 are arranged to form the rectangle shown below. A curve is drawn by inscribing a quarter circle in each square and joining the quarter circles in order from shortest to longest. What is the length of the curve? Okay, so since the circumference of a circle is 2 pi r, that means a fourth of the circumference is pi r over 2. We're going to just add up these pi times 1 over 2 plus pi times 1 over 2 plus pi times 2 over 2 plus pi times 3 over 2 times 3 over 2 plus pi times 5 over 2. So that is the same as pi over 2 times 1 plus 1 plus 2 plus 3 plus 5 equals pi over 2 times 12. So that is 6 pi. That is B. All right. So, yeah, we could say that pi is equal to 3.14159, and then there's a non-repeating infinite decimal. But this is inaccurate, right? It's just an approximation. This is the most accurate way to write pi. And then we actually, with the Greek letter, there's no E. Cool. So, okay, so what about pi? Two formulas are ancient formulas, pi r squared. Well, even that is an approximation, right? There's a dot, dot, dot. If the answers don't have pi, the symbol, then you need to know what pi is. But all of these have pi. So we don't need to worry about it. Let's see. Hong, was that helpful? No? Well, just think of pi as a stowaway. Stowaway. Sorry, there's two W's in that. Well, yeah, it's not going to work for everyone. It's not going to click the first time every time. As long as you know that the area of a circle is pi times its radius squared and its circumference is 2 times pi times its radius, you don't need to know what number this is because your calculator knows. All right. A stowaway is like a person or like some sort of vermin that is on a ship that is like going somewhere, but they don't have a ticket. So pi is just along for the ride. It doesn't actually do anything here, though. Anyway, let's go to problem 12. In the figure below, each circle will be filled with a digit from 1 to 6. Each digit must appear exactly once. The sum of the digits in the neighboring circles is shown in the box between them. What digit must be placed in the top circle? So, this is just what I got after trying around. So we got 5, 4, 1, 6, 2, 3. Feel like we're going quick? Okay. I can slow it down if you want. I am kind of interested in your opinion um on if this was easier or harder than other versions of the AMC8 that you've taken before. So send it to me privately if you want to tell me your opinion. Why 5? Well, to be honest, I don't have a very good reason for this except for I just started placing down numbers and saw if I could make it work. So for instance, there's 4 answer choices here. Let's try 2. If I have a 2 here, then 2 and 9 would make a 7, and then 7 and 10 would make a 3. 3 and 8 would make a 5. 5 and 5 would make a 0, but 0 is not allowed, so it can't be 2. Okay, then we could try 3. If we try a 3 here, then this becomes a 6, then this becomes a 4, then this becomes a 4. However, we can't have 2 4s, so it's not a 3. Let's try a 4. If we try a 4, then this becomes a 5, then this becomes a 5. That's not allowed. But if we do a 5, 5, 4, 6, 2, 3, 1, then this does match up. And we're good. So it is 5. Okay, interesting. Sorry, I didn't mean to just stop there completely. I was just reading people's opinions. Thank you for telling me your opinion. You don't get it? So, there's two conditions. There's condition one, each digit must appear exactly once. And the sum of the digits in the neighboring circles is shown in the box between them. Sorry. So as soon as I put a 5 here, then this must be a 4 because their sum has to be 9. So whatever goes in this circle needs to be what you add to 5 to get to 9. Once we have a 4 in here, this box has to be a 6. Yeah. I didn't try anything fancy. There's only 4 answer choices you need to check. No need to do anything here to like a mental backflip. No mental backflips are required. Usually I would discourage doing mental backflips and just try to find the easiest way to do it. All right, so the figure below shows a tiling of 1 by 1 unit squares. Each row of unit squares is shifted horizontally by half a unit relative to the row above it. A shaded square is drawn on the top of the tiling. Each vertex of the shaded square is a vertex of one of the unit squares. In square units, what is the area of the shaded square? It's okay if you want to guess on this. Oh, someone else wants to explain it? Okay, cool, cool, cool. So this is 1 long and this is 3 long. So according to the Pythagorean theorem, 1 squared plus 3 squared equals 10 squared. And so this area is 10 squared, but this area is the same as this area. So the answer is A. All right, so Jamie picked 3 equally spaced integer numbers on the number line. The sum of the first and second numbers is 40, and the sum of the second and third numbers is 60. What is the sum of all 3 numbers? So we have A, B, and C, except A is equal to B minus D, and A is equal to B plus D. And so they tell us that A plus B is equal to 40, and B plus C is equal to 60. So I just want to say we don't actually need to take the square root at any step in oh, you're right, it's 10, not 10 squared. You're right, it's 10, not 10 squared. Thank you. But we don't need to take the square root at any step here because they're asking for the area. So square roots are not required. What is a Pythagorean theorem, bro? Great question. So whenever we have a right triangle with legs A and B and side length C, then this is always the same situation as A squared plus B squared is equal to C squared. It's not -4 because, sorry, I got 1 question wrong. So 1 question here. So this would be 8, but this would be 8 minus 1 minus 1. So that's a 6. Good question. Yeah, of course. Think of it as trigonometry. I don't know if that's a helpful word to say if you don't already know the Pythagorean theorem. So the Pythagorean theorem, funny story, is like 1,000 years at least older than Pythagoras. This is a very ancient theorem. People have known about it. I'm gonna guess longer than there has been writing. That's my guess. You know, I could be wrong, but I'm pretty sure people have known about the Pythagorean theorem for a long time. What in the world is trigonometry? Great question. You know, I got a degree in mathematics and I've been thinking about trigonometry for 15 years. And there's still more to learn. Trigonometry is so cool. So, sorry. I'm getting sidetracked. Even though we have a ton of time, we're more than halfway through the test. I still want to not jump around too much. So, I'm going to reread problem 14. Jamie picks 3 equally spaced integer numbers on the number line. The sum of the first and second numbers is 40, while the sum of the second, third numbers is 60. What is the sum of all 3 numbers? So our numbers, let's call them A, B, and C. And since they're equally spaced, we have that A is equal to B minus D for some D. And A is equal to B plus, or sorry, not B. C is equal to B plus D for the same D. Okay, so they tell us that A plus B equals 40 and B plus C equals 60. If we add these up, we get A plus 2B plus C is equal to 100. Or B minus D plus 2B plus B plus D is equal to 100. But the minus D and the plus D cancel out, so we get 4B is equal to 100, or B is equal to 25. And that would make A equal to 15 and C equal to 55. If we add these up, then we get to, wait, did I make a mistake, chat? Yeah.
No, isn't it?
40.
35? 35, no?
Yeah, 35.
35, no?
Let me,
Since it's
Wait,
25.
what's the 14
yeah,
again?
35.
15,
35.
25, 35.
Thank you, guys. I had a brain fart there, but I appreciate the corrections. So 25 plus 15 plus 35 adds up to 75. Cool. So Elijah has a large collection of identical wooden cubes, which are white on 4 faces and gray on 3 faces that share an edge. He glues some cubes together face to face. The figure below shows 2 cubes which are glued together, leaving 3 gray faces visible. What is the fewest number of cubes that he could glue together to ensure that no gray faces are visible, no matter how he rotates the figure? Okay, so I like this problem. It takes 4 cubes. I'm just going to draw the situation that works. You take all of their faces pointing inwards, and then you put them together like this. And so that is A. So consider all positive 4-digit even integers consisting of only even digits. What fraction of these integers are divisible by 4? So these numbers look like this. A, B, C, D, where A could be 2, 4, 6, or 8, and B, C, and D could be equal to 0, 2, 4, 6, or 8. It actually doesn't matter what these are. These have basically no contribution to its divisibility by 4, and whatever we choose here won't matter. What only matters is these two. So we only need to know, out of all the combinations that we could have here, how many of them are divisible by 4. One of the easiest ways to do this without thinking too hard, so I'm just going to present the brainless way of doing it, if you don't mind. We have 0, 2, 4, 6, 8. 0, 2, 4, 6, 8. So if we write this as a digit, this is 0, 0, 0, 2, 0, 4, 0, 6, 0, 8, 2, 0, 2, 2, 2, 4, 2, 6, 2, 8, 4, 0, 4, 2, 4, 4. Oh, some people are getting impatient. I don't mind though. 4, 8, and then 6, 0, 6, 2, 6, 4, 6, 6, 6, 8. 8, 0, 8, 2, 8, 4, 8, 6, 8, 8. And so from the pattern, we can see that it's going to be 3/5. So that's D. Can I re-explain 15, please? So it all comes to this drawing. Take your 4 cubes, right? And orient them so that the gray faces are facing their neighbors. So we have 4 cubes like this, and the gray faces are facing their neighbors. We got to shove them together like that. But there's no way to do it with less cubes. So for this one, I'm going to recircle these in green. Thank you, Samuel, for doing that earlier. That was very helpful. So there's 3 good rows and 2 bad rows, and each row has the same amount of each. So that's 3/5. Good row, bad row. It's a good, or sorry, good column. I mean, are these numbers divisible by 4 or are they not divisible by 4? I hope that was helpful. Okay, cool. So, 4 students are seated in a row. They chat with the people sitting next to them, then rearrange themselves so that they are no longer seated next to any of the same people. How many rearrangements are possible? So I'm just going to call this A, B, C, and D. And it just depends on who are we going to have here to start out with. So we could have A, but they can't be next to B, so they could be C or D. But if we have C, then it would be B or D here, so that doesn't work. So you have A, D. D cannot be next to C, so this would be B. But then this would have to be next to C, so that doesn't work. So we can't have an A next to this at all. Okay, we could have B.
Has to be D.
Well, let's see. Let's see. So, I don't think it's D.
I mean, like next. Because B is next to A and B is next to C.
Oh, yeah. Okay, of course. But one moment. I actually didn't do my notes correctly. I remembered it correctly, though. Let me just spoil the answer before we go through this, because no one is saying what the correct answer is. The correct answer is A.
Yeah.
So then this is B, and then this is D, and this is C, and this is A. Or we could have... no, we can't have that. Sorry, A and then C. Or you could have C, A, D, B. But I'm pretty sure that these are the only two.
It is the only two.
B and C cannot be next to each other, Marvin. So, all right. Any questions about this one before I move on? All right, I'm moving on. In how many ways can 60 be written as the sum of 2 or more consecutive odd positive integers that are arranged in increasing order? There's like smart ways to do this, but I'm just gonna write down the brainless way. Just by testing them out, there's only two: 29 plus 31, and 5 plus 7 plus 9 plus 11 plus 13 plus 15. So I'm going to put a star next to this one because the way to do it is just a little bit tedious to like convince yourself that those are the only two ways. For this one, you just have to find the number of odd factors, I thought. There's more than 2 odd factors, though. Well, it is very possible to overthink this one. How do you know, for instance, that there's not more than these two? It's just a little bit of work to do that. So I'm not going to go through it yet. I'm going to wait till the end to actually go through all of it. Okay, so Miguel is walking with his dog Luna. When they reach the entrance to a park, Miguel throws the ball straight ahead and continues to walk at a steady pace. Luna sprints towards the ball, which stops by a tree. As soon as the dog reaches the ball, she brings it back to Miguel. Luna runs 5 times faster than Miguel walks. What fraction of the distance between the entrance and the tree does Miguel cover by the time Luna brings him the ball? So, okay, so look, if Luna is equal to 5 times Miguel, then Luna plus Miguel is equal to 6 Miguels, right? So instead of, we can just add their speeds basically together. And Miguel over Luna plus Miguel is equal to Miguel over 6 Miguels, which is 1/6. So he goes 1/6 of the total. right? 1/6 of the total, though, is, however, 1/3 of the way to the tree. So the answer is D. Does this make sense? Cool. So the land of Catania uses gold coins and silver coins. Gold coins are 1 millimeter thick and silver coins are 3 millimeters thick. In how many ways can Taylor make a stack of coins that is 8 millimeters tall using any arrangement of gold and silver coins, assuming order matters? So we can't have one gold coin. So let's count silver coins. So let's say we have 1 silver. Whoa, that's not how you spell silver. I'm sorry, guys. 1 silver and then 5 gold. Then there is 6 ways of stacking these, right? We could have 2 silver and 4. If we have 2 silver, then 2 gold. And there's also 6 ways of stacking these. Or we could have, pardon me, 8 gold. And there's 1 way of stacking this. So that is 13. Right? Yeah, I got that right. Okay. I'm glad you guys are so invested in this. Problem 21, I'm just going to say a little bit of vocab because problem 21 is related to something that I studied in my master's degree. I have a master's degree in statistics and data science, and I have an undergraduate degree in pure mathematics. And this is like a combination of both. This is something called hypergroups. But they somehow managed to fit this concept into a question for 8th graders. So I thought that was really cool. So Charlotte the spider is walking along a web shaped like a 5-pointed star. Shown in the figure below, the web has 5 outer points and 5 inner points. Each time Charlotte reaches a point, she randomly chooses a neighboring point and moves to that point. Charlotte starts at one of the outer points and makes 3 moves. Revisiting points is allowed. What's the probability that she is now on one of the outer points of the star? So instead of trying to worry about the probabilities of moving between all the points individually, here's what we're going to do. We're going to group them. I don't mind if you guys talk to each other in chat, but just be nice to each other. That's all I'm saying. Just be nice. So I'm going to group these into the inside points. And then outside of that, we have the outside points. So we have these 2 regions, right? And I'm just going to worry about the probability of going from inside to outside. So she starts on one of the outer points, and then we have 3 moves. If she's on an outer point, she has to go to an inner point. But if she's on an inner point, she could either go to one of the 2 inner points next to each other or one of the 2 outer points. So she has equal probabilities of going inner or outer. So she could go outer or stay on inner. Okay. Once she's on an outer point again, then she has to go to an inner, but this is 3 moves, so she would stop. If she's on an inner point, she could go to an outer or an inner, right? So at the very end, after 3 moves, there is a 1/3. Wait, why am I wrong? Oh, because not all of these have equal probabilities of happening. So the probability of this path is 1, this is 1/2, and this is 1. However, this is 1/2, this is 1/2, and this is 1/2. So this path actually counts for twice as much. So twice, let me say that here. Okay, so let's write it out. If we had the probabilities, it would be 1/2 plus 1/2 times 1/2 plus 1/2 times 1/2 for each of these outcomes, but this would be 1/2 times 1/2, and that would be 1/4. Since this adds up to 1, these are probabilities, these add up to 1. Oh, whoa, hey, what happened? Here's what is gonna go forward. I don't think there was any racism. As long as we're nice to each other, no one's chat privileges need to be taken away. All right, I'm just gonna give everyone a blanket amnesty. We're all just gonna relax. We're here to talk about math. It's sometimes we misunderstand each other, but let's just move on. Does that sound fair? Why is it times 1/2? Because when you're on an inside point, you can either move to one of the 2 ways to the inside points, another inside point, or one of 2 ways to an outside point. But if each path is equally likely, then 2 of them will keep you on the inside and 2 of them will keep you on the outside. Cool. No one has to apologize. We all we're all subject to brain rot. We all miscommunicate. As long as we're just nice to each other, then no one needs to have any consequences. All right, problem 22. The integers from 1 to 25 are arbitrarily separated into 5 groups of 5 numbers each. The median of each group is identified. Let M equal the median of the 5 medians. What is the least possible value of M? So look, we have 3 groups, right? A, B, C. Oh, sorry, that yellow is hard to see. My apologies to everyone. I'm going to go back to blue if you don't mind. So we have A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, and U, V, W, X, Y. So let's say that these are in order, and so we have these 3 are the medians, right? C, H, and M are the bottom 3. Well, we need to have at least all of these numbers be less than or equal to these medians, right? So we could have something like 3, 4, 5. Sorry, pardon me. Whoa. Let's try something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then 16, 17, 18, 19, 20, 21, 22, 23, and 24, 25. And in this case, these are going to make the medians as small as possible. And so the median of the medians is 9. So that's A. Guys, again, I don't want to take away your chat privileges, but let's keep it on math, please. You don't get this question? You're talking about problem 22? So let's say we put them in order first, right? And we just say that these are the medians, and including this one. I just have to write it in such a way that the median of the medians is the smallest possible. So the way that I did that is I put all the numbers from 1 through 15 over here, and then I just packed the rest of the numbers over here. And then that would make the median of the median 9. There's no other smaller answer, so we don't need to think that hard about why. All right, so problem 23. Problem 23, in my opinion, could have been problem 3. Problem 23 is really simple once you see how to slice it up correctly. So Lakshmi has 5 round coins of diameter 4 centimeters. She arranges the coins in 2 rows on the tabletop as shown below and wraps an elastic band tightly around them. In centimeters, what will be the length of the band? So let's chop it up into parts that are pulled around the circle and the parts that are not touching the circle. And what you might notice is that from here to here it's straight, and then we turn, and then here to here it's straight, and then we turn, and then from here to here it's straight, and then we turn, and then from here to here it's straight, and then we turn. And so the turning part we can separate by itself into its own circle, and then the other part is a trapezoid if we put it together. The length of this trapezoid is going to be 4 times the radius, so that's going to be twice the diameter. So this is 8, this is 4, and this is 4, and this is 4. This is 2, so the circumference is 2 times pi, so this is 4 pi plus 4 plus 4 plus 4 plus 8 is 20. So the answer is C. Are the top bends, they're each, great question. Great question. They are each 1/6. The top bends are 1/6, and then the bottom bends are 2/6. So this is a 1/6 turn here, and this is a 2/6 turn. Does that make sense?
What is a radius?
A radius is the distance from the center of a circle to a point on its circumference. Diameter is twice that. If the diameter is 4, then the radius is 2. I'm sorry, my friend. How is it 4, 4? Okay, so this segment right here is the same as this segment between the centers of these. So this right here is the same as this right here. But this is 2, so this has to be 4. This is 2, and these segments are the same. So that has to be 4. This is the same here, 2, 2, 2, so that's 8. This is the same here and here. Maybe I wasn't as clear as I should have been about that. Does that help? How's it 4 pi? Because the circumference is equal to 2 pi r, but we know that r is equal to 2, so then we get this number, which is equal to 4 pi. Because we have to put together the circular parts plus the straight parts. Why use 4 pi? Because all the circular parts add up to, so it's kind of rotated here, but this 1/6 turn goes here, this 1/6 turn goes here, this 2/3 turn goes here, and this 2/3 turn goes here. So they all add up to 4 pi. Use coordinate geometry. Oh no, coordinate geometry. So this is a problem where you should not coordinate bash. I usually don't even teach coordinate bashing until high school because it's a tool that is easy to abuse. I have zoned out during the test before and lost time. Yes. June, how do you feel about the problem overall now? All right, thank you so much for asking questions. It really helps. Coordinate bashing, it's a high school strategy. It will always work, but because it will always work, sometimes it's too much work. sometimes there's like way too much middle steps that you don't need to do. That's the price for having something that's guaranteed to work. So the notation n factorial is defined as the product of the first n positive integers. For example, 3 factorial is 1 times 2 times 3 times 6. Define the superfactorial of a positive integer divided by n to the exclamation point in the exponent to be the product of the factorials of the first n integers. For example, 3 superfactorial is 1 factorial times 2 factorial times 3 factorial is 12. How many factors of 7 appear in the prime factorization of 51 superfactorial? What is the answer for 18? I'll scroll back up, but I'm not going to re-explain it. It's B. I'll explain it at the end, sorry. It's just going to take a little bit more time, so I wanted to... Problem 18 might be the hardest one just because you have to spend a lot of time doing some algebra to be sure that it's correct. So, for the numbers 0 through 6, they each contribute 0 to the number of 7s in the prime factorization. For 7 through 13, they each contribute 1. 14 through 21, they each contribute 1. Through 20. In fact, all the way from 7 to 48, they each contribute 1. And then 49 contributes 2. And then 50 to 51 contribute, that's not correct. That's not correct at all. I just got owned, sorry. This contributes 1, and then 14 through 20, that contributes 2, and then 21 through 27, that contributes 3, and then 28 through 35, that contributes 4, and then 35 through 34, and then 35 through 41, that contributes 5, 42 through 48, that contributes 6, 49 through 51, each of these actually contribute 8, because 49 has just one more, 7 that it's contributing than before. So we have 6 times 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 8, which is equal to 6 times 21 plus 8, which is equal to 6 times 29. Correct me if I'm wrong, chat, because I think I am. It should be E. It should be E. What am I missing here? So this is equal to 174. I'm 3 above. Oh, plus 3 times 8. Yep. There we go. There we go. There we go. Thank you. Thank you for the correction. One thing you might notice as you get older is that adults make mistakes all the time. You should only trust your own logic. So this is 6 times 21 plus 24. No, 7 times 21. These are 7 of them. 7 times 21 plus 24 is equal to 147 plus 24 is equal to 171. Oh, 24 missed messages that I missed. The whole superfactorial thing. So 3 superfactorial is equal to 1 times 1 times 2 times 1 times 2 times 3. 4 superfactorial is equal to 1 times 1 times 2 times 1 times 2 times 3 times 1 times 2 times 3 times 4. N superfactorial is kind of crazy. That's equal to, if we don't know n, we just have to know how to create it. So it has a pretty long formula, right? That's a really annoying formula, but that's how you would write it down. All right, problem 25 is super simple, actually. So in an equal angular hexagon, all interior angles, oh, nice goal, measure 120 degrees. An example of such a hexagon with side lengths of 2, 3, 1, 3, 2, and 2 is shown below, inscribed in an equilateral triangle ABC. Consider all equal angular hexagons with positive integer side lengths that can be inscribed in ABC with all 6 vertices on the sides of the triangle. What is the total number of such hexagons? Hexagons that only differ by rotation or reflection are considered the same. So the easiest way to think about this is that we can put these little caps on this regular hexagon, right? And we have a choice about which caps that we can put on. Since we're allowed to rotate, though, it only matters how many caps that we could put on. So we could have 0 caps, 1 cap, 2 caps, or 3 caps. But there's only 4 total ways, so that's A. Wait, am I lying? I am lying. Oh, because we can also remove some. We could also remove it and have a cap like this. But we can't have both. However, there's going to be one that's not allowed. So we have 3 options here, 3 options here. Okay, so it's not A, and 3 options here. However, we can't have all 3 be like this. So we have to subtract 1 case. There's one situation that's not allowed, so that's E. Congratulations, Eric. Congratulations, Yifi. All right. There's other ways of doing it, and that's kind of a hack way of doing it. It's kind of hard to understand what it's asking for. Yeah. Very understandable. Not necessarily. If all the caps are on, it's not a triangle. If all the caps are sliced off, then it is. So that's why we have to remove 1 case. But if we have all the caps on like this, then it's 1, 4, 1, 4, 1, 4. You can leave if you want. So let's look at this one. If you can stick around if you want to see a proof that there are only 2 here. Not really happy with this, but no, because those aren't consecutive odd numbers. Later, Warren. Later, Derek. Oh, that's a scary face. The answer to 16 was D. The answer to, oh, Jenny, great to see you. The answer to 20 was D. Anyone else want to see one that we missed? 24 was E. How does 1/6 turn into 1/3? Because the total distance is twice the distance around the tree, but the distance to the tree is half. How many people are still here? Still 30 people. That's crazy. Any other questions? All right. So only 25, you still don't understand. So we have three options for this. Three options for this and three options for this. And we can think of these as separate cases. Since they're separate cases, we add up 3 plus 3 plus 3. But one of the cases is not allowed, where all three are like this. Well, only one of them is not allowed, right? We're not allowed to have the case where all of them are sliced off like this. All right, so for number 18. So we have 60 is going to be, if we have, so A plus 2, A plus 4, dot, 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 A plus 2 times D, or 2 times N minus 1. Then 60 is going to be equal to N over 2 times 2A plus 2 times N minus 1, or 60 is equal to N times A plus N minus 1. Now, A is odd, but 60 is even. So N is even. N is going to be the number of terms. So we could have 2, 4, 6, or 8. However, if this is odd and this is odd, then this is even. So we need to look for pairs of factors of 60 that are both even. So 1 and 60 won't work. 2 and 30 will work. 3 and 20 will not work. 5 and 12 will not work. And then 10 and 6 will work. So this is, we had 2, this we had 6, and then I believe that's it. 15 and 4, that doesn't work. And 10 and 6, these are by themselves, that's fine. 15 and 4, 30 and 2. 60 has 12 divisors, so we should have 6 pairs. We do. Okay, so we're good. Yeah. All right. So there's only 2 possible ways of doing it. All right. You guys are free to go. Enjoy the rest of your weekend. Good job, everyone who participated, and I will see you later.